All right, so welcome to day 2 of Filecoin Orbit. I'm tremendously excited to be sharing this 1-year anniversary with the Filecoin ecosystem. My name is Raul Kripalani, and I've been at Protocol Labs for 3 years and a half, where I've been tech leading projects like Libby2P, Test Ground, and several Filecoin initiatives. My latest focus these days is the Filecoin virtual machine, and this is what I'm here to talk to you all about. So today, the Filecoin network is a storage and retrieval-centric network. We can think of these two primitives as together being the layer 0 of the stack. And today, Filecoin is able to provide reliable storage and retrieval for humanity's most valuable data. And you've heard it many times before all throughout this event, but the Filecoin network is currently providing 12 exabytes of data and capacity being offered by 3,400 and more storage providers. But storage is only the start. The goal of the FEM, which is what we're introducing today and announcing to the world, is to enable users to deploy their own smart contracts on the Filecoin blockchain. We call them actors in the Filecoin programming model. And this introduces the ability to perform on-chain computation or computation of a state, which can be thought as sort of like resolving the layer 1 of the Filecoin capability stack. Once you have layer 0, which is storage, and you have layer 1, which is computation over state, so this is on-chain computation, there are many new downstream use cases that can emerge either on-chain or also off-chain. And those off-chain use cases are what we call layer 2 use cases. And those are things like computation over data. I'm going to go into more detail in the next slides. Now, this slide just illustrates some of the most powerful use cases that the FEM can enable. And these are use cases that I'm personally very excited about. These are things like data DAOs, the Dataverse, and tokenized data sets, NFTs minted, exchanged, and stored under a single roof under the Filecoin network. Things like replication workers. Imagine anybody should be able to write a new smart contract that makes new deals to maintain a specific level of replication of a specific data set or data being added to the network by a given client. Things like trustless reputation systems or storage bounties and auction mechanisms. If you're familiar with Filecoin today, you know that clients have to find providers to store their data with. But imagine inverting that process such that clients post bounties and have providers compete for storing that data. Those use cases are currently not possible, but will be possible with the FEM and layer 1. Things like futures and derivatives on storage that compose in a DeFi-like fashion, or things like, for example, conditional loans to providers for sector pledging, or time-locked retrieval, perpetual storage, you name it. There are so many things that can be built on the FEM that we're so excited about. And we really want to get you thinking about the possibilities here. Now, if you think about it, use cases like these are actually hard, if not impossible, to build with centralized and cloud storage solutions. And this is where Filecoin and the FEM are really going to shine. I'm going to deep dive into some of these use cases in the next slides. Dataverse and data DAOs. Imagine kickstarting the dataset economy by tokenizing datasets in order to capture and represent the value of those datasets to society. Imagine if those tokens were harvested and exchanged between peers to request things like computation to be performed on that data. Things like, for example, validation or transformations, feature detection and extraction, machine learning, analysis, and a lot more. Now, chain these processes together and you will end up compounding the value and augmenting the value of those data sets iteratively. And just to top it all up, imagine deploying self-governing entities on-chain to steward, maintain, curate, preserve those data sets that are really valuable to humanity. And like potentially those data DAOs could be funded by crowdfunding. So this is one of the use cases that I'm personally really excited about to see happen with the FEM. Another use case that is very interesting is replication workers. So imagine being able to write actors or smart contracts that take one piece of data and make sure that it's replicated n times across the network, and obeying and using a user-defined policy that specifies things like the region selection or the latency, price, or other things, other characteristics. Now, this thing would actually solve a pain point present today in the network, where clients, if they want to store n copies of a piece of data with a number of providers, they have to perform the data transfer of that data to every single provider. So this would basically offload the cost of that data transfer to somebody that is to an actor that is being incentivized for it in a trustless manner. Another really exciting thing is the ability to have layer 2 systems commit onto the layer 1 of the Filecoin blockchain. And this provides consensus-backed commitment and provability facilities for solutions like bridges, such as, for example, textile bridges and other bridges that have been built with the Flow blockchain, with Near, with the Ethereum blockchain, Polygon, and a lot more, who are currently operating without a layer 1 commitment on the Filecoin network. So kudos to them. But really, to make this whole process end-to-end provable and traceable, having a layer 1 medium where layer 2s can commit to is extremely important. Another set of use cases that I'm very excited about is bringing richer functionality to storage market, such as, for example, auto-renewing deals, the ability to renew deals without repeating data transfers over and over again when deals expire or when deals get slashed, self-repairing deals. So say, for example, a provider has sectors that fail and they want to recover that data. Instead of having clients send that data over to them again, they could harness those replication workers to have that data sent back to them again and the sector restored. Things like, for example, retrying deals, where clients dispatch their deal data to a depot and pay a small fee to have the deal data be transmitted, satisfactorily delivered to the provider. Things like time-locked retrieval, making storage deals with data that cannot be retrieved by anyone until a specific window of time elapses, trustless reputation systems with so many providers in the Filecoin network. How do you pick the ones that you want to deal with based on the quality of service, guarantees, performance, latency, region? There are already a bunch of solutions in the ecosystem, but imagine being able to build a overlay network of nodes that are patrolling the network, performing observations and recording them on the blockchain so that reputational scores can be calculated in a trustless manner. And also they can be traced and disputable if there is any disagreement. Now, another use case that is super, super exciting, and you can hear more about this use case later on in a talk by Porcucoin, is decentralized verifiable computation. So really, once you start adding computation onto the Filecoin blockchain, you end up in a place where you have both computation and storage under a single roof. And I think that is one of the strengths and differentiators of the Filecoin network. Imagine being able to define a computation to be applied on data, incentivizing its execution all the way to the end, and being able to certify that the result and the output is verifiably correct. And link all of that with the concepts that I just mentioned earlier about the Dataverse, about tokenization of data sets, and suddenly you're in a whirlwind of computation that is pushed to the edges, that is pushed to the providers that have that data, and with an incentivization circuit and a provability circuit with which you can verify that the results are correct. So really, there are boundless opportunities for innovation that layer 1 programmability is going to unleash in Filecoin. And the Filecoin community is super creative. They have just made it evident in the last year, and you've seen everything that has been presented in Filecoin Orbit so far. So I'm pretty sure that there'll be no shortage of ideas hitting mainnet very soon after the FEM launches. Now, let me talk a little bit about this thing that is going to make all of this on-chain innovation possible. This is the Filecoin virtual machine, and this is the technical part of the talk. I would love to cover this in a lot more detail, but I don't have a lot of time today. But the good news is that you can find a lot of this information in the FEM entry point repo, which I've just linked on that slide. Want to give a huge shout out to community members such as Stebalian, XBeat, Boris Mann, Aaron Chick, and many others that have been contributing over the last few weeks to refine these discussions and to refine and to define the architecture and design of the Filecoin virtual machine. Now, just to give you a little bit of history, the Filecoin virtual machine and the layer one programmability has been in the roadmap for a very long time, and it was rekindled by FIB discussion 113. If you want to go into it, take a read, understand how things got kickstarted again or resumed again. The thing that got us really prompted to prioritize this work now is the overwhelming positive reaction to this FIB from developers, storage providers, ecosystem partners, and a lot more. This got us incredibly motivated and made us jump right into action to make it happen for the Filecoin community. Now, as I said before, the user programmability had always been part of the roadmap in Filecoin since the very beginning, but the road to get where we are today wasn't easy. Filecoin had been in development for 6 years prior to mainnet launch. And just to build a secure and permissionless decentralized storage network, we had to solve fundamental challenges and limitations that led to important breakthroughs. Things like proof of spacetime, proof of replication, expected consensus, unbiasable randomness, ZK snark applications, and a lot more. And at that time, it wasn't clear what the future of blockchain VMs was going to look like. Was there a standard emerging with the EVM? Was this kind of like the silver bullet? Was WASM, this new kid on the block that was receiving a lot of attention and traction, going to be the thing? There was also secure ECMAScript that was being proposed, LLVM IR, some blockchains were looking into that. So during that time, we decided to focus on layer 0, the storage and retrieval layer, and to kind of like wait it out to see where the VM ecosystem trended towards and consolidated towards. Now, just to give you a little bit of a few light touches on what the inspiration of the design of the Filecoin VM has been. There are several key concepts here. The virtual machine hypervisor model inspires the architecture of the FEM, and like hypervisors, containerization are two concepts that inspire the architecture, and the ability to host multiple runtimes in an isolated manner over a common base layer. Another concept from computing that really resonates with us, and like I think this is really where we strongly think that this is where blockchain computation will go in the future, is the actor model. And concretely, Erlang OTP as a runtime is a paradigm that inspires us. We particularly like the functional approach, the self-healing mechanisms, the location transparency, and the messaging model, which are great concurrency primitives to build parallelizable computation on blockchains over time. Now, just to give you an overview of the technical design of the FEM is fundamentally based on WebAssembly. We looked at other things like LLVM, IR, the JVM, secure JavaScript, and secure ECMAScript, and other options for the core layer of the FEM, and ended up settling on WASM. For those who are not familiar with WASM, it is a portable execution format that initially was built for the web and in theory meant to replace JavaScript, but which has transcended to other runtimes. And it has seen a massive traction and uptake in blockchain ecosystems. So we believe that joining this traction and joining this community will also help speed things up and solidify things together as a blockchain community with other members and other partners. Now, one key aspect of the FEM is that one thing that it should do is interact with IPLD state tree data efficiently. And we're putting a lot of attention to this. Now, native actors can be written in languages that compile to WASM. This doesn't mean that you want to use any language that compiles to WASM, because you do have to be aware of the runtime costs of certain languages and the overheads of certain languages. One language that we think produces really succinct and nice WASM is Rust. So we're building the SDK, the reference SDK in Rust. And one key aspect of the FVM is that it has support for foreign runtimes, foreign VMs, such as the EVM, and eventually the Agoric S potentially, LLVM-IR, BPF, and other virtual machine models. Now, the thing that I wanted to stress is that we're trying really hard to launch the FVM with EVM compatibility out of the box. We've heard strong requests from the Filecoin developer community for the FVM to support EVM and Solidity compatibility out of the box. So we made this a priority. With the FVM, developers will be able to deploy Ethereum smart contracts to the Filecoin blockchain directly. And this makes a lot of sense because the Ethereum community has amassed a massive corpus of useful and, most importantly, audited and battle-tested smart contracts over time. Like, for example, ERC20 tokens, NFTs, DAOs, flash loans, you name it. So having the ability to take these contracts and deploy them as is to the Filecoin blockchain is a great onboarding ramp for developers that are already familiar and trust those contracts. Now, the Ethereum ecosystem has amazing developer tools like Truffle, Remix, Hardhat, plugins for IDEs, and a lot more. And also, Solidity has become the de facto smart contract programming language that smart contract developers out there basically master. So this facilitates their onboarding into the Filecoin ecosystem. Now, just to give you a little bit of a technical view on how we plan to make this happen, the plan is to adopt an EVM bytecode and WASM approach instead of working off Solidity directly. This choice guarantees almost perfect execution, fidelity, and parity, and mitigate risks otherwise present in the Solidity to WASM compilation path. We concretely looking at adopting the Sputnik VM project, which has emerged as the de facto WASM-compatible EVM implementation in the industry. And it was initially developed by the folks at Parity, but it's also been adopted by the blockchains like Near in Project Aurora. We still have many difficulties to solve around the mapping between the EVM and the FVM models, things like the memory and storage model in IPLD, gas accounting, calling conventions, representing events and logs, but we're confident that we'll figure this out, and also with your help. So please make sure that you join the discussion to help build this out. Now, a few touches on the data layer itself. We can consider the FVM a computation engine for IPLD data. The Filecoin state tree and the actor states are IPLD objects, and the FVM essentially executes computation on those inputs to produce outputs. So building libraries and primitives to interact with IPLD data must be a core priority, and it deserves a lot of attention. We're also looking at implementing an IPLD-based interface description language to describe actor interfaces. So you can think of this as kind of like the SOAP, the WSDL and SOAP, or the IDL and gRPC for on-chain actors, which will then power tools to generate clients for cross-actor calls. It is also worth mentioning that this VM isn't directly tied to and tightly coupled to Filecoin, and it can be adopted in other contexts, such as IPFS and IPLD itself. If you're interested in the nitty-gritty details of how all of this will work, I totally encourage you to check out Stepstock later today, which is on IPLD and WASM. Now, another thing that I wanted to mention is that user-defined actors will exponentially increase the demand for space in the blockchain, and the significant research going on at Protocol Labs within Consensus Lab, looking into things like sharded and hierarchical consensus with parallel execution. And this has a bunch of implications in the FVM, such as the kinds of calling patterns that will happen depending on whether calls are intra-shard or cross-shard. And you should totally attend Marco's talk later today on consensus scaling and sharding for the Filecoin network. Now, if you want to, I've just kind of given a few light touches on the technical design of the FVM. If you want to learn a lot more, then you can go into that repo, explore the docs, and contribute. There's a lot more detail in the technical documentation in that repo. Now, onto the part that I guess most people are interested in, which is when will this ship? we've got into that part. All right, so the roadmap consists of 4 phases. Phase 0 is to have the FVM implemented, running the built-in system actors and having canary deployments of various clients, Filecoin clients on mainnet, running a non-programmable FVM. And we expect to have this done by the end of this year. All of these timelines are very tentative. Phase 1 will introduce changes to the network to prepare the network for user programmability. And this will happen in Q1, by the end of Q1 in 2022, we believe. Phase 2 will be all about launching user programmability proper with native actors and EVM foreign actors. And the goal here is to really enable user programmability. And we think that this will happen sometime in Q2 2022. And in phase 3, we'll redesign the system actors for improved programmability against them. And this is also going to ship around Q2 2022. There are still many unknowns here, so these timelines might change in reality, but hopefully these will be the we'll be able to stick to them, and with your help, we'll be able to figure things out as well. So how can you get involved? First of all, if you want to check out the FIP discussion, make sure that would be one thing that I recommend you to do. Next thing is to follow and engage in the Filecoin project FEM repo itself. Another thing that you can do is join the FEM channel on the Filecoin Slack to stay tuned with everything that's happening. If you actually want to get your hands dirty and you want to start designing and building stuff, admittedly, it is still a little bit early, but you can really help out in fleshing out technical detail by helping in the discussions and kind of like participating in the discussions in the FEM repo, where we're investigating all of these uncertainties and kind of like unknowns that we still need to figure out. And of course, one thing that we'll love people to start doing is to start thinking about the use cases that they want to build. And thinking as well about kind of like those base libraries and tools and examples and actor templates that are going to make life easy for everybody in the ecosystem. So we really imagine things like, for example, Open Zeppelin in the Ethereum ecosystem, which is a very nice toolbox library to emerge in the FEM ecosystem. Things like local test sandboxes, test frameworks, deployment tools, IPLD IDL generators, and a lot more. These are things, if you're interested, start talking to us in those forums, in the GitHub repo and in the FEM channel on Slack, and we'll figure things out. Now, before I go, I just wanted to leave you with one thought. The FEM is basically a greenfield ecosystem that is just getting started now with a new programming paradigm. And there is an opportunity to start thinking early on about composability and modularity upfront, drawing inspiration from kind of like, the ERC model in the Ethereum ecosystem and DeFi composability. So really start thinking in terms of Filecoin standard interfaces for reusable primitives that can be composed with one another to create complex actors, things like payment channels, vesting schedules, multi-sigs, and voting mechanisms, loans, and a lot more. We're really, really excited to see what you'll build on the FEM. I hope you're excited, just as excited as us, or even more. And make sure that you stay tuned for things like grants, bounties, and other incentives to kickstart an innovative ecosystem on the FEM and build on the FEM. Thank you so much. Oh, and before I go, I wanted to just plug in a job opening for, in case you're interested in working on the FEM and also in building the future of decentralized computation. Make sure to check out this URL to see what opportunities are open. Thank you very much and have a nice one. Enjoy the rest of day 2 of Filecoin Orbit. Happy 1-year anniversary.